Hello friends, welcome. Friend, this is the second video of the video series which I am doing on direct to device, means satellite communicating to your smartphone directly without the need for a terrestrial network. In the earlier video, this is the title of the video right in front of you, which I did yesterday. I spoke about Elon Musk applying for their Gen 2 satellite with the Indian space regulator, which is called InSpace, and how that Gen 2 satellite is going to enable direct to device, means your smartphone receiving satellite signal directly from the satellite without the need for a terrestrial network. Today's video is going to be the second video, which will be on spectrum. Ultimately, it is all about spectrum as far as any kind of mobile communication is concerned, because without spectrum you really cannot reach the mobile device. You have to reach through airwaves. So in case of satellite also, the same principle is applicable, but there is a difference because satellite spectrum actually has larger footprint and it can spill over across border, whereas in terrestrial spectrum is limited to the geographical boundaries of the country and easily manageable. So satellite, the spectrum is much more challenging. The second problem with satellite spectrum is because the device is very small and it transmits very low power, transmitting in a particular spectrum band to the satellite, which may be 400 to 500 kilometers from the surface of the earth compared to base station, which may be a maximum 10 kilometers. Therefore, choosing the right band becomes very, very important. And the third important point here is, as far as spectrum is concerned, that you need to also take into consideration the economies of scale of the devices. You cannot choose a spectrum band where there are no economies of scale, because the device actually is the key. The price of the device is the key. If the customer cannot afford the device, then the service becomes completely useless, right? Even if you have the best of the technology, you will not be able to reach the customer because customer will not be able to afford the device. And that also depends upon spectrum. So we are going to talk all about this in this presentation. So the title of the presentation is, in DWD, spectrum is the strategy, right? As I told you, in all mobile communication. So let's talk about what is D2D, means direct to device, and how it is different from a terrestrial network. Now here is the satellite right in front of you. Now satellite will be communicating to a mobile phone. So there will be two paths. One is the downlink, another is the uplink. Simple. I have shown two arrows here, but you just take into consideration that satellite talking to the mobile phone and the mobile phone talking to the satellite. And this is typically a low frequency band. This is not high frequency band because you can't communicate to the mobile phone using the satellite back and forth using a high frequency band, because these satellites are moving pretty fast. They might be stationary and the height of this satellite will be very, very high, 36,000 kilometers. But if they are at the lower orbit of 350 kilometers or 400 kilometers, they will be moving pretty fast. So this is one leg. Second leg is that satellite has to reach the terrestrial network in order for these mobile phones to talk to them. So there has to be a feeder link, right? So every satellite will have two links, right? One is directly to the phone, another is talking to the gateway, right? So this gateway will talk to a higher frequency band, right? Because the antenna is quite big here. Here the mobile phones are pretty small. Therefore, this is the typical structure of a satellite network. Satellite in the sky talking to the mobile phone or talking to the gateway. Gateway will be in the Ku band or the Ka band, and the access part of the spectrum will be at the lower frequency, which will be either L band, S band, or the IMT spectrum, right? Now, this is the snapshot. You can take the snapshot of this chart, and here all satellite specific bands, which can be candidate bands as far as India is concerned, which can be used, are listed down here. So we have got a 700 megahertz band, the 800 megahertz band, the 900 megahertz band. Then we have the L band, which is not an IMT band, means it is not a 5G band. Then you have the 1800 megahertz band, the 2100 megahertz band, and we have the S band. And I have listed down the theoretical maximum. Per operator, the numbers can be different. Okay. Now, in D2D, two interference realities exist, right? One is the L and S band. As I told you, friends, in LS band, there are no terrestrial network. Terrestrial networks are absent. But in path B, which uses the IMT spectrum, means the 5G spectrum or the 4G spectrum, which is 700, 800, 900, 1800 and 2100 megahertz spectrum, you have to deal with the terrestrial network. Means these spectrum bands are not empty. They are already being used by the terrestrial network, right? Whereas L band and S band can be used by the satellite. There could be some deployment there, but it is reasonably free. If a satellite is using L band, it may be occupied, but if it is not, it will be free. For example, in S band, if there are no satellites there, it will be reasonably free because there are no terrestrial network. Do you understand now what I'm trying to talk about? So in case of IMT spectrum, which is the 5G, 4G spectrum, you have to deal with interference. And that is the very, very important point, because you are already transmitting in the spectrum. And I'll tell you what the problem is, that, here is the base station, which is talking to the mobile phone, let's say. Okay? And the satellite, which is at a distance of, minimum 400 kilometer, and the base station is a distance of 10 kilometer. So this distance is quite, different, these distances to the mobile phone. And therefore managing the RF spectrum, which is coming to the device, and then controlling and integrating the two, or selecting a particular path versus the other, becomes quite challenging. And therefore, definitely when you are using satellite, overhanging on top of the IMT spectrum, there will be some capacity loss in the IMT band. Whereas in case of LNS band, this problem is not there, because these are not contaminated with the terrestrial networks 4G and 5G. These may be contaminated, but with some other kind of deployment. Okay. So this is the IMT device rich coexistent heavy path. As I told you that we have got 700, 800, 900, 1800 and 2100. These bands, there is an advantage here. The advantage, just like I told you, there is a disadvantage, that these are going to be heavily used by the 5G and 4G networks. But the advantage is that because the phones are already hooked onto these bands, means they are already having the capability to receive signal in these bands. Therefore, the economies of scale in the IMT spectrum can be much higher compared to L and S band, which are new. There are no deployment yet in L and S band as far as IMTs or 3G and 4G and 5G technologies are concerned, right? So this is the advantage. Disadvantage is because there is a lot of interference management issues, which I'm going to talk about. I probably have to take you through some of the charts which I have not uploaded in my system. I'm going to pick some of the chart and show you how interference is going to be a problem across circle, across borders, and you have to take care of all these issues in order to ensure that the service becomes viable. It does not clash with the IMT spectrum, which belongs to a different operator in a different circle and across borders. We have to deal with that, right? Now, therefore, neither path is a winner yet. So summary is that in LNS band, you have relatively interference free from a terrestrial network point of view, right? But these do not have economies of scale. These are parallel paths. Whereas in case of IMT spectrum, 4G and 5G spectrum, these are mainstream spectrum. Economies of scales will be there, but managing interference is going to be a big challenge, which I'm going to show you, right? Especially as far as India is concerned. Okay. So this is the situation. The problem is fragmented holding. And let me just pick up some of the charts. Let me just pick up one 900 megahertz and open and show it to you, right? Here is the 900 megahertz chart. Here is it. Okay. Now, if you see here, this 900 megahertz, let me just, here it is. And I'm going to play this in front of you. Let me just blow this to the full screen and I play this. So if you see this, what will happen after some time, you'll see that all these operators, you'll find different colors and different circles. And because satellite is going to be radiating across India, all this cross-border interference is going to play a very, very important role. So this is 900 megahertz band. See, all the colors belongs to different operator, right? So let me just pull out the 1800 megahertz band, which is a band of interest, right? So let me pull this out and I'm going to talk about the 1800 megahertz band here. Just a minute. Here is the 1800 megahertz band. So here I'll play this. You'll find that this band has lot of cross-border discontinuities. For example, VI is here, Reliance Jio is a different color, Bharti is here. Then if you look at here that as the channels, because as I am playing this, the channels are basically getting changed, and the colors will also keep on changing. So unless the band is harmonized across the country uniformly, it is impossible to utilize this band. So there are a lot of harmonization has to happen across the various circles in order for the band to get used. And we have to deal with interference across border also, because this is radiating from the sky, and there could be spillover in Pakistan, in Nepal, in Bangladesh, and other countries, right, which is in the neighboring border. Since these bands are not yet recognized by ITU for MSS capability or MSS services, therefore if India has to use these bands like 1800, 900, 2100, they have to ensure that there are no cross-border interference to a different country. Otherwise, it will be a violation. Okay, so you have to follow the Radio Regulation 4.4, right? I'm not going to pull out the Radio Regulation 4.4 to show you that what kind of legal obligation that exists as far as India is concerned. Okay, so where is it? Yeah. So this is so you need to have one common spectrum across all the circles. If you have different spectrum across different circles, you really cannot make it work. Now, Airtel proposal is that start with the 1800 and the 2100, which I spoke yesterday. In their submission to TRI, Airtel says that we don't have to wait for the WRC 27. We are going to start right now and let us use 1800 and 2100 after we harmonize. I told you yesterday, and I will show it to you right now. Where is my this? Yeah, here is it. So here you see the 1800 megahertz band. This is the band plan that I have listed out in my website, right? This is the link of that website. So here you will find that if I pick Airtel, you'll find that the Airtel is not contiguous across all the circles. Like it will come up immediately. You see that these are the green color, and you'll see that this is not contiguous. If it was contiguous, it should be something like this. Just like if you see, as far as Geo is concerned, which I showed you yesterday, you see this is uniform across all circles. These violet colors, these have the harmonization might have happened because this is an old plan. I'm quite sure that Geo might have converted this into a very uniform spectrum across all the circles. Similarly, in 900 megahertz band also you will face the similar problem. Let's say Vodafone Idea wants to use 900 megahertz for their AST SpaceMobile, just like AST SpaceMobile is using in Vodafone UK. If I pick Vodafone Idea here, you will find that uniformity does not exist in all the circles. These are all fragmented. So you need to harmonize first before you can use this spectrum. Otherwise, you will face this kind of problem which I showed you, right? Look at this, right? So this is the problem that you're going to face. So this is a problem. Now, VII already spoke about. Geo, in their filing, which I am going to show you, yesterday also I showed you, this is the filing where they have mentioned, and if you download these files, you will find that Geo has mentioned that apart from all the other spectrum band, they specifically have mentioned about 800 and the 1800 megahertz spectrum band, right? Here is the bands. Here are the bands: L band, S band, and the 1800 and the 800 megahertz spectrum band. For Geo, 800 is pretty important because, as I told you, that they have contiguous spectrum across all the boundaries, all the geographies, right? This is the chart here. So they have contiguous. So Geo could be, if they are able to use 800 and they make the 800 megahertz band pretty lighter, because this is a 4G band, they can move all their 4G customer or most of their 4G customer to 5G. So this is going to become a little bit, lighter compared to what it was when 4G was the mainstream technology. So once it becomes lighter and there are less customer as far as 4G is concerned, satellite actually can overlay on top of this band and will cause less interference compared to what it could have done if this band was densely populated and heavily used. Okay. So let's go further. So this is the advantage of Geo, right? So they don't have 20 megahertz, they have a 10 megahertz across pan India. So all the circles, they have uniformity, which will make their life much more easier compared to Airtel and Vodafone. So now you talk about smartphones. Smartphone is not the only play as far as D2D is concerned. There are a lot of other devices like watch, trackers, connected vehicles, industrial IoT, maritime remote beacons, etc. This could be used very easily in the L band. Now you may ask me, if L band is available, then why aren't we using it? The problem today is, friends, that if you look at the L band today, This is the L band, which I showed you earlier. The L band spectrum is, let me just show you L band clearly so that you understand where it stands, L band, where it stands. So if I, let me just pause and bring that chart before you. No, I have already with me. Okay, let me pull this here, right? So here is the in-space approval, right? So in-space approval, if I go to in-space approval, I can clearly see Inmarsat. So Inmarsat has been using, let me just zoom this a little bit so that you will be able to see where the L-band spectrum is as far as Inmarsat is concerned. Where is it? Just a minute. I'll go here and I'll do a search here. Find, okay? And I'll say Inmarsat. So here is it. So you see that this is the spectrum block. All the spectrum as far as L-band is concerned is occupied by Inmarsat, where the approval, they have got an in-space approval on 20th October 2025, and it is valid up to 9th April 2028, and they can keep on renewing this approval because if they don't change the satellite. So if Inmarsat, which is currently Viasat, is already using L-band, how can it be made available to other players, satellite players? You may say that what is the problem? What is the problem? Because satellite is a shared spectrum. Very easily, L-band can be made available to other operators also. But the problem here is, friends, that Inmarsat is using a geostationary satellite. And the geostationary satellite has got larger footprint. Therefore, this band cannot be shared with anybody else. So if you really want to leverage this band, which is currently being used by BSNL for their sat phones, you need to come out with a different regulatory structure where Inmarsat should be allowed to share their spectrum as a wholesale retailer within the SCN model, which TRAI is currently having a consultation. They are doing the consultation. So if Inmarsat, let me go to my slide and I'll show you what I mean by this. So Inmarsat is sitting here, which is Viasat, and there is an approved gateway as far as Inmarsat is concerned, as far as BSNL. So they can have a different gateway and they can have other mobile operators which are on ground buying capacity and wholesale from Viasat. BSNL can continue to use this service. I'm not saying that BSNL should stop it. But since Inmarsat has got a lot of spectrum here, you see, a lot of spectrum is here, and BSNL may not be able to use the full capacity. If this spectrum is made available to other Indian operators using a model or where Inmarsat or Viasat can share their spectrum to other mobile operator, then this band can be harnessed properly. Without which, friends, this L band is not available as far as India is concerned for any other deployment. So this is a regulatory structure that we have to build to enable Viasat to share their spectrum with other mobile operators who are doing different types of other services. So 3 operators, 3 different incentives, right? Airtel, what they will do, because they don't have any satellite with D2D capability, so they will tie up with a foreign operator. VI already have announced their partnership with AST. Jio is building their own satellite network. So they are going to go on their own. So this is basically the overall structure. But we really don't have a winning D2D band yet because every band has got challenge. As I told you, L band is occupied. We need to create a regulatory structure in order for Viasat to share their spectrum. S band is still not available. It is not free yet by the government. Then we have the Airtel versus IMT route, lot of challenges because you have to do harmonization of their spectrum. Then Starlink should be allowed to operate in India. They should get all the security clearance and all kinds of requirements, regulatory requirement is there. Jio has to now start their service. It will take 4 to 5 years, maybe more, for them to come out with a meaningful network so that they can start leveraging their 800 megahertz band. And Viasat Inmarsat can be a low-hanging fruit if the SCN model can be opened up pretty soon so that Viasat can wholesale their spectrum capacity to other licensee who want to seek capacity from them and launch services. Not smartphone because it's a geostationary satellite. They can do a lot of other IoT type of messaging services, maybe smartphone or different type of trackers. That is possible because that is a low-hanging fruit. Anyway, smartphone will take some time to mature because 3GPP is coming out with the standard, and today the standard is not yet ready. So device compatibility and other challenges you will face as far as smartphone connectivity is concerned. but L-band can be a low-hanging fruit. Okay? So we may not wait for WRC. If you really want to get ahead in this game, we can create a regulatory structure because Viasat is already operating on ground, or if you have an IMT band which is harmonized, you can allow a player like Starlink to start operating, and along with the Indian player, start sharing spectrum. They can share spectrum with Starlink, and you can start empowering the ecosystem today. You build the ecosystem today, because when you start today, then only the volumes will come and the device prices will go down. If you wait for 4 or 5 years, by the time it will be too late, because you need to start experimenting now and create the ecosystem on devices. So friends, that's all in my presentation. I hope that you understood, right? I'll come back with the third video on this series. Until then, thank you for watching, and I'll come back very soon with that video. Thank you very much, friends.